This week's DMT Insight is on mathematical thinking in the age of digital dependence. So you might look at students who are on screens and seeing that they are absolutely getting everything. They got it. But then you give them a piece of paper to solve a problem, to work on a story problem, and that understanding dissipates. So that raises a question. So why do students appear to be proficient when they're working on screens, yet struggle to retain, transfer, and reason about the mathematics over time? So this DMT Insight has been inspired by a new book that just came out called Digital Delusion by Jared Cooney Harvard. It was pretty amazing. And so that inspired me to be thinking about how does that really affect us as teachers as we work with kids in elementary and middle school mathematics? It's not that the technology is bad. The issue is if we're using it for cognitive outsourcing. So are we letting the tools think for the kids? And we're starting to see that, especially using a lot of AI right now. So let's go back to analogy that Dr. Harvard. And so he was a former teacher and he is right now a neuroscientist. And I love the analogy that he gave is, do we want to strengthen our muscles? So we go to the gym, and when we get to the gym, we see all of the digital tools doing the weightlifting for us. That's not gonna work. I thought that was a great way of analogy of thinking about how we use digital tools. That's what it means by cognitive outsourcing. Okay, so let's talk about working memory. So mathematics takes a lot of working memory, and part of it is about connections and the structure of mathematics. There's a lot of information. So number one, you might be thinking about the procedures, the algorithm for solving algebraic problems. There's so much information going on. And all of these are these different strands that kids need to build over time. So there's addition, there's subtraction, there's multiplication, there's division, there's fractions, there's algebraic problems. So if you have problems with any of those, your working memory is now focused on one issue and you've forgotten about everything else to really solve this algebraic task. So I'd like you to think about mathematics not as this hierarchical stacking of ideas one at a time. Once you learn it, you're good to go. Actually think about it more as strands that are interwoven into this fabric that creates this really tight understanding of the mathematics, and they build on each other over time. So there's a really good quote by Sweller in 1988. When too many elements must be coordinated simultaneously, students experience overload and performance declines. So we're focused on just observing things online, clicking and dragging, versus are we handwriting our notes? Are we actually drawing things out? This is so critical. Part of this comes from what we talked about before with Jerome Bruner, the inactive iconic symbolic, where the iconic, the visual model is the key to really developing deep understanding. So these are really critical ideas that students need to do by actually drawing out the number lines, bar models, area models, and also then writing definitions. Another really good example is we have this figure here. We call it a quick draw. It kind of looks like a block C. And then what you're trying to do is look at the relationships. What's the shortest? What's the longest lines? Are they horizontal, vertical? Is one 2 times as long as another 3 times? And that is a really important idea in kindergarten and first grade to be building. And then by 4th grade, they'll get this area model here. And they have to determine, given certain unknowns and certain lengths, determine what those unknown lengths are. That's a really important idea, and if you've been doing all these drawings of models early in your career, you're going to be very successful now later. That will lead to algebraic reasoning when you're doing graphing on an XY axis. So when you are handwriting the definitions, you're using these visual models, that embeds the structural components of the mathematics. It creates a well-connected schema of ideas in the brain, and that is what allows for transfer of information from one situation to another. Now, I'm going to paraphrase Harvard. He has a really amazing quote in the book. I'm just changing it just a little bit. So when you're doing the handwriting and the visual models, this activates a broader neural system involving language, motor processing, spatial reasoning, and memory encoding. That's amazing. So just by doing that process, the brain is firing in all these places. And that's not happening if you're letting the computer, the digital tools, do the work for you. Now, it's totally possible if you have like iPads and you're actually drawing and doing things, absolutely fine. So again, it's just being balanced of what we're allowing the digital tools to do. We don't want them to allow the cognitive outsourcing and having the work being done by the digital tools. Okay, now we're going to go back to a question, why do students forget? So retrieval, recall, and developing transfer is so critical. So one thing I would like you to think about. So imagine driving down a road and you recognize the road. That's kind of the easy way. I've recognized it, that's all I've done. That's not putting anything to long term. But when you try to recall the street, now draw a map of where we're going from one place to another, and you have to do that work. That's the ability that really puts the information, encodes it into your brain, which then allows you to be able to recall it later and then use that information to solve problems. So a couple things that are really nice. Having a really well-designed student workbook is great for kids so that they can actually be working the problems, writing down the definitions, graphing things, excellent. So something we developed at Math Success by DMTI is very practice sheets. We use this kinder through 6th grade, and they're amazing in the sense that they're like a worksheet, but there's 3 different things that you're working on. You're working on context, an iconic model, and symbolic. You're given one of those, and you have to produce the other 2. And when you go back and forth, even from 1st grade working on compare problems, it's amazing the knowledge that kids build, the understanding that they develop, which then allows for them to be so proficient in mathematics. So this section has a really good quote by Rediger and Kopik. Learning strengthens when students actively retrieve relationships, reconstruct ideas, and apply their knowledge across different contexts, which is exactly what we were just talking about. So then what does this mean altogether to really develop math thinkers? So you have to think pencil and paper are not outdated. They're not old-fashioned. You can actually use them. You should use them. Yes, we can use some other things like I said, like the iPad, but we have to think about using digital products more as practicing, not as building the understanding. The 2 are slight differences. And so as kids are drawing the models, they are writing down definitions, they are building the architecture from the beginning of really understanding and developing the framework for deep mathematics across the grade levels. So one of the things we do at Math Success by the Developing Mathematical Thinking Institute, we've created the digital platform so that teachers can use to animate things, which is powerful, but then we have the student workbooks for students to work on. We have the very practice sheets. We focus on the models, we focus on language, we focus on structure. It's so critical. And we have also supplemental activities, target activities and games that kids actually play together in groups, that's with centers. And we do have digital games too, but with the digital games, we have support where how do we actually use the games and then activate our thinking to solve the different problems. So check out our resources, we have a lot of them. They do everything that we've talked about today. To conclude, mathematical understanding is woven. It's not stacked. And you, nor the digital tools, can do that for them. They must hold on to each strand to weave and build that math knowledge for themselves.
Yeah.
Oh, there it came.